Have you ever wondered what happens when poisonous chemicals enter an animal's body? Many toxic substances do not disappear quickly. Instead, they hide inside organs, fat tissues, muscles, and even bones. This process, known as the storage or bioaccumulation of toxicants, can silently affect the health of animals and disturb entire ecosystems. From pesticides in fish to heavy metals in birds and mammals, these harmful substances travel through food chains and become more dangerous over time. In today's video, we will explore how toxicants are stored in animal bodies, why it happens. Let's see how this process occurs. Accumulation of toxicants in specific tissues by binding to circulating plasma proteins. Both mechanisms reduce the concentration of the free toxicant in the blood plasma. Storage can be permanent like mercury in the hair or temporarily like organic compounds in fat tissues. Other than blood protein and fat, toxicants can also be stored in bones, liver, kidney, muscles, central nervous system, etc. First of all, we will talk about storage of toxicants in plasma proteins. Binding of toxicants to plasma protein or other body tissues alters its distribution. Stored xenobiotics are in equilibrium with blood. As xenobiotic is metabolized or excreted, more toxicant is released from storage site. 60 to 80% of plasma proteins most important in maintenance of osmotic balance. These include albumin, ceruloplasmin, alpha and beta proteins, gamma globulins, transferrin. The amount of a specific toxicant that will become bound to plasma proteins varies widely. Like antipyrin, secoborbital, and warfarin, which show 0, 50, and 99% binding with plasma protein respectively. Ceruloplasmin is a glycoprotein that converts ferrous iron to ferric iron, which then binds to transferrin. Transferrin that binds most of the ferric iron in plasma and helps transport it across cell membranes. Alpha and beta some are important for transport of materials through the blood. Gamma globulins are immunoglobulins produced by lymphocytes. All types of toxins like acidic, basic, or neutral can bind to protein through covalent or ionic bond and become unavailable to cause toxicity. Let's see how storage occurs in bones. Bone appears to be rather static, but it is not. Bone is alive and will bleed since it contains blood vessels. Composed of proteins like collagen, glycosaminoglycans, and proteoglycans. Bone also contains a mineral salt hydroxyapatite that consists of calcium, phosphate, and hydroxyl group. It also contains specialized cells like osteoblast, which are bone-forming cells that produce extracellular proteins and also create a chemical environment that favors the natural or biogenic precipitation of hydroxyapatite. While osteoclasts are bone-resolving cells, during the normal bone formation processes, calcium and hydroxyl ions are incorporated into the hydroxyapatite calcium matrix. However, some chemical elements follow the same kinetics as calcium and hydroxyl ions and therefore can be substituted for them. For example, fluoride can substitute hydroxyl radical, while strontium and lead can replace calcium on the average about every 10 years. Thus, any toxicant stored in the matrix will eventually be released to re-enter the circulatory system after every 7 to 10 years. Lipophilic substances prefer to be stored in the fat tissues. Fat is found in various areas in animal body, like subcutaneous fat that make half of all stored fat, around the kidneys, in the intestinal omentum, in the genital areas, between muscles, behind the eyes, in folds on the surfaces of the heart and intestines. As with storage in bone, The triglycerides deposited in these sites are continually exchanged with the blood and may be redeposited in other adipose tissue cells. During weight loss, fats break down and toxins are discharged into bloodstream. Toxic man-made chemicals that are absorbed into the body and stored in fat may be released into the bloodstream during the rapid fat loss, which may occur during heavy exercise, starvation, and diseased condition. Liver, generally known as detoxifying organ and storage site. As we have discussed in previous topic of distribution, it has a large blood flow to mass ratio. Nutrient-rich blood directly coming from digestive system through hepatoportal circulation also contains some dietary toxicants. Additionally, various biochemical processes are taking place in the liver like glycogen storage, urea synthesis, ornithine cycle, and biotransformation, etc. As a result of this reaction, many toxins are produced as byproducts. The liver deals with toxins by breaking them down into safer substances, eliminating them through bile, or repackaging them into a safer form. Last resort, liver will store toxins itself to protect the rest of the body. Liver has specialized blood vessels, known as sinusoid channels, lined with immune cells called Kupffer cells. These channels facilitate the connection between arterial and venous blood flow, allowing for efficient uptake of metabolites, immune surveillance. Liver filters toxins through these channels. Kupffer cells engulf the toxin, digest and excrete them through a process called phagocytosis. Liver contains ligandin protein. It binds bilirubin and organic anions from blood and help to detoxify or remove them from the body. Called phagocytosis. Liver contains ligandin protein. It binds bilirubin and organic anions from blood and help to detoxify or remove them from the body. Metallothionein is a cysteine-rich, metal-binding protein that has various biological functions like it maintains metal homeostasis, detoxify heavy metals through chelation therapy, provides cellular antioxidative defense by stabilizing metal ions. Kidneys also act major storage sites due to high blood flow rate, which is more than 4 times greater than that of heart muscle, which preferentially exposes it to high concentrations of toxicants. Storage in the kidneys is associated primarily with the cells of the nephron. Instead, soft tissue associated with the nephron is exposed to the toxicant or its metabolites. Lipophilic toxins stored in the myelin and axon sheath of central nervous system. Similarly, they may store in the epididymal fat and prostate glands. Mucosal lining of respiratory tract, in the gallbladder, spleen, and fetus. Some toxicants stored permanently in the hairs and skin. skin is impermeable. To be stored through the skin, a toxicant must pass through the epidermis, sweat glands, or hair follicles. The rate-limiting barrier is the stratum corneum, which is outermost layer of the epidermis that chemicals cross by passive diffusion. Thanks for watching. Like and share this video. Subscribe this channel to get more informative videos on various topics.